p72, and our final thoughts on some periodic table ideas. So a term that pops up once in a while is an allotrope. So allotropes, these are the different forms of the same element. And within allotropes, the reason that they represent different forms is because each allotrope has a slightly different bonding pattern. And bonding patterns determine properties. So different bonding patterns that occur between identical atoms. And because the bonding patterns are different, they form different structures. And when you change the structures, different structures have different properties. Allotropes typically only occur between elements that make up groups 13 to 16. Just know a couple of the common ones. So for carbon, carbon has the most known allotropes, but the more common ones include the diamond, graphite, and charcoal. So all three forms of the element carbon you are probably familiar with. Diamond, jewelry, hardest known substance known to mankind. Graphite, that's the quote-unquote lead in the pencil, where it's very soft and you can write on a page. And charcoal is pretty crumbly compared to the rest in a darker color. So in charcoal, we use it to start fires. We don't use graphite or diamond to start and fuel a fire. So three forms of carbon, because of the difference in their bonding, they have different properties. Oxygen has two known allotropes. There is O2, which is the form of oxygen you and I need for respiration, but there is also O3, which is a gas, and you might not recognize the formula, but O3 is what we refer to as ozone. We need the ozone layer to protect the Earth, but if you watch the weather, certain areas of the country will have high ozone warning days because being overexposed to ozone causes damage. Phosphorus has a few different allotropes, and the way that we can tell the difference between the phosphorus ones is the color that they display. So the most common allotropes of phosphorus are recognized or referred to by their color. So there is red phosphorus, there is black phosphorus, and white phosphorus. So each color is the result of a different bonding pattern. So you can see the bonding patterns up here. All right, so ions. We talked about ions already, so a quick little recap. So an atom is always our reference point because that's what's on the periodic table, information about an element's atoms. And if it's an atom, its charge is 0 because it represents a neutral structure. So in an atom, it has a net charge of 0. It's neutral because the number of electrons equals the number of protons. They have the same negative count as they do positive count. When an atom goes to form a cation, the resulting structure has a positive charge. The reason it has a positive charge is because now the number of electrons is less than the number of protons. So in order to form a cation, the atom, it loses one or more electrons to form the cation. And because particles were lost from its structure, the cation is always smaller than the atom. Whereas some atoms will form an anion, and it's an anion if the net charge is negative. And in this case, that means that the number of electrons is now greater than the number of protons. Why this happens or how it happens is because the atom gains one or more electrons. And as a result, because particles were added to its structure, the structure becomes larger. So an anion is always going to be larger than the original atom. And the last part is the radioactivity, about the elements. So some elements are completely radioactive. So radioactive elements are what we describe as unstable. And as a result, the nucleus falls apart. So you might want to replace, so the nucleus of the atom falls apart over time, and it emits dangerous particles, which we call radiation, like the beta, alpha, positron, gamma. All elements with an atomic number of 84 or higher are radioactive. They only have radioactive isotopes. So they have no stable isotopes. Elements with an atomic number of 83 and below have both stable and unstable nuclei. So a great example of this would be carbon 12 versus carbon 14. Carbon 12 is stable. It has a 1-to-1 proton to neutron ratio, where carbon 14 is unstable, so it is radioactive and it emits beta particles. The only exception, so know this exception, is technetium, Tc. All known isotopes of technetium are radioactive. Memorize technetium, but a good way of predicting or knowing that an element is radioactive on our periodic table is an element with atomic masses shown in parentheses. So maybe it says like parentheses 239. So that mass, atomic masses in parentheses, is a pretty good indicator it is radioactive.